Assalamualaikum and hi everyone! Today we are going to be presenting about Emart24 queuing system.
Assalamualaikum and hi. Before we get started, let's meet our group members. First, my name is Siti Nur Adia and my matrix number is 2023605148.
Assalamualaikum and hi. My name is Muhammad Ashraf bin Jamazin. My student ID is 2023611414.
Hi, my name is Nashar binti Fauzi and my matric number is 2023848632.
Assalamualaikum and hi, my name is Nurin Amanina binti Rahimi and my matrix number is 2023684336.
Next, for introduction, Emart24 is convenience store retailing daily goods and call me to the customer. The customer make their own order at the cashier and pick their orders at the pickup area, which is applicable to some of the full items. There is an influx of customers during the peak period and queues might be created in service counters. For working hours, for Emart24 Tanah Merah Kelantan open every day except public holiday, and it open at 8 AM and close at 2 AM. Next, this is a picture that has been taken by our group when we are doing our group project. This is customer waiting in line and servicing the building, and next is servers. Next, for arrival characteristic, pattern of arrival rate or lambda equal to 60/7 customer per hour. This is the average number of the people entering the system. The size of calling population is unlimited or infinite, and behavior of arrival a patient customer.
Next, waiting line characteristic. Emart uses the first in, first out queue discipline. Customers are served in the order they arrive. The queue line is the number of customers in line.
Now, I will explain the service facilities characteristic of the system we observe at Emart. First, in terms of the number of channels or servers, the system uses a single channel system, which means there is only one cashier serving customer at a time. Next, for the number of phases or stations, the system follows a multiple phase system. This is because customers go through more than one step, such as ordering at the cashier and the food preparation. Lastly, for the number of waiting lines, there is only one waiting line. All customers line up in a single queue before being served, which helps make the process more organized and fair. Overall, the service system can be described as a single-channel, multi-phase system with a single waiting line, which we use as the basis for our queuing analysis.
Next, this table shows the observations data collected at Emart on 7 January 2026 from 3:15 PM to 4:30 PM involving 15 customers. For each customer, we recorded the arrival time, the start and end time for phase 1, the start and end time for phase 2, and the total time spent in the system.
Next, we are going to measure the performance for single channel for queuing equation. First, we let lambda equals to mean numbers of arrival per time period and mu equals to mean number of customers per time period. Let's calculate for average number of customers in the system. The equation is lambda over mu minus lambda. For first phase ordering, we substitute the amount of lambda and mu into the L equation. So, the average number if customer in the system for first phase ordering is 0.5, while the average number of customer in the system for phase 2 food preparation is equals to 3.5.
Now, I will explain about the average number of customers waiting in the queue, represented by LQ. We calculate LQ using the formula LQ equals to lambda squared divided by mu in bracket mu minus lambda, which average applies to an MM1 queuing system. For the ordering phase, after substituting the values into the formula, the average number of customers in the queue is 0.17. For the food preparation phase, the calculated value of LQ is 2.72 customers.
Next, for average waiting time in the system for W, phase 1 ordering, lambda equal to 16.67 and mu equal to 50 customers per hour. We use W equal to 1 over mu minus lambda, and we get 1 over 50 minus 16.67 multiplied with 60, and we get 1.8 minutes. And for phase 2 food preparation, lambda we get equal to 16.67 and mu 21.43 per hour. We get W equal to 1 over mu minus lambda, and we get 1 over 21.43 minus 16.67 multiplied with 16, and we get 21, and we get 12.6 minutes.
Next, for the average waiting time in the queue, the equation is equals to lambda over mu bracket mu minus lambda. We substitute the amount of lambda and mu into the equation. So, the average waiting time in the queue for phase 1 ordering is equals to 0.6 minutes, while the average waiting time in the queue for phase 2 preparation is equals to 9.8 minutes.
Next, utilization or rho for each phase of the service process. Utilization tells us how busy the system is, and it is calculated using the formula rho equals to lambda divided by mu. For the ordering phase, we divided lambda by mu, we get a utilization value of 0.33. For the food preparation phase, using the same formula, the utilization is 0.78.
Next, for probability that no one or zero customer in the system, know as well P0 for phase 1 ordering, lambda 60.67 and mu 50 customer per hour. P we got from earlier calculation, P equal to 0.3334, P0 equal to 1 minus 0.3334, and we get P0 equal to 0.67. And for phase 2 food preparation, lambda equal to 16.67 and mu equal to 21.43 per hour. P equal to 0.78, 0.78, P0 equal to 1 minus 0.78, and we get P0 equal to 0.22.
Operating characteristics explain how well the queuing system performs. In this project, we use MM1 model for each phase at Emart. This analysis is based on the arrival rate and service rate, which we input into QF for Windows to obtain the system performance result. To ensure our answer is correct and precise, we double check using QM Windows. First, from the main menu, we select waiting lines and then choose MN1 model because each phase has only one server. Then just put our title, then click on no cost because we didn't have any cost for queuing system. Next, we enter the data for phase 1. The arrival rate lambda is 16.67 customers per hour, and the service rate mu is 50 customers per hour. The number of server is set to 1. After entering all the data, we click solve to obtain the operating characteristics for phase 1, such as server utilizations, average waiting time, and average number of customers in the system. To ensure our answer is correct and precise, we double check using QM Windows. First, then we repeat the same step for phase 2. The arrival rate remains 16.67 customers per hour. Meanwhile, the service rate is 21.43 customers per hour. And the number of server is also 1. And then we click solve again to generate the operating characteristic for phase 2. Then we repeat the same step for phase 2. The arrival rate remains 16.60. The result shows higher server utilizations and longer waiting time compared to phase 1. In conclusion, this project helped us understand how queuing theory works in real service system. We observed the cashier counter at Emart, collected real data, and analyzed the system using QM for Windows. For phase 1, the service rate is higher than the arrival rate. This results in low waiting time and small queue. Therefore, the single cashier is sufficient and the service is efficient in this phase. However, in phase 2, the service time However, in phase 2, the service time is longer and server utilization is higher. This causes longer waiting time and shows that phase 2 is the main source of delay in the system. Overall, the project improved our understanding of queue performance and show how QM software can help management make better decisions to reduce waiting time and improve customer satisfaction.